What is grid computing?
Grid computing is a processor architecture that combines computer resources from various domains to reach a main objective. In grid computing, the computer on the network can work on a task together, thus functioning as a supercomputer. Okay, let me make you clear on who can use grid computing. There are four of them, which is a government, military, teachers, and businesses.
How grid computing works. In general, a grid computing system requires at least one computer, usually a server, which handles all administrative duties for the system. A network of computers running special grid computing network software, and a collection of computer software called middleware.
For the grid architecture, there are five of layer. For first layer is fabric that provide the resources to which shared access is mediated by grid protocol. For the second layer is connectivity layer that define the core communication and authentication protocol required for grid specific network function. For the third layer is resource layer that define protocol, API, and SDK for secure negotiation, initiation, monitoring, control, accounting, and payment of sharing operation on individual resources. And for second last layer is collecting layer that contain protocol and services that capture interaction among a collection of resources. And for the last layer is application layer. These are user application that operate within VO environment.
Types of grid. There are three types of grid: computational grid, data grid, and scavenging grid.
Computational grid. A computational grid is focused on setting aside resources specifically for computing power. In this type of grid, most of machines are high-performance servers.
Data grid. A data grid is responsible for housing and providing access to data across multiple organizations. Users are not concerned with where this data is located as long as they have access to the data.
Then scavenging grid. A scavenging grid is most commonly used with large numbers of desktop machines. Machines are scavenged for available CPU cycles and other resources. Owner of the desktop machines are usually given control over when their resources are available to participate in the grid.
Cousins of grid computing. There are three of them: parallel computing, distributed computing, and peer-to-peer computing.
Okay, now we move to the method of grid computing. The ASIC method, which is distributed supercomputing, high throughput computing, on-demand computing, data intensive computing, collaborative computing, and logistic networking.
Distributed supercomputing. Distributed supercomputing is a combination of multiple high-capacity resources on a computational grid into a single virtual distributed supercomputer. Examples: climate modeling and computational chemistry.
High throughput computing is a computer science term to describe the use of many computing resources over long periods of time to accomplish a computational task.
On-demand computing. On-demand computing or ODC makes computing resources such as storage capacity, computational speed, and software applications available to users as and when needed. It is also used for specific temporary projects, known or unexpected workloads, routine work, or long-term technological and computing requirements.
Data-intensive computing, a class of parallel computing application which use a data parallel approach to processing large volume of data. Collaborative computing. On the right side, collaborative computing allows users to work together on documents and projects, usually in real time, by taking advantage of underlying network communication system. On the left side, whole new category of software has been developed for collaboration computing, and many existing applications now include features that let people work together over network. Here are some examples: Microsoft Office and Exchange.
Logistical networking. It is a global scheduling and optimization of data movement. It contrasts with traditional networking, which does not explicitly model storage resources in the network. It's also called logistical because of the analogy it bears with the system of warehouse, depots, and distribution channels. There are many advantages of grid computing. First, it can solve larger, more complex problems in a shorter time. Second, it will be easier to collaborate with other organizations. Third, it can make better use of existing hardware.
Disadvantages of grid computing. First, the grid software and standards are still evolving. Second, the learning curve to get started. And the third one is non-interactive job submission.
Conclusion for this topic: grid computing provides a framework and deployment platform that enable resource sharing, accessing, aggregation, and management in a distributed computing environment based on system performance, user quality of service, as well as emerging open standards such as web service.